In this video, I'll present some of the characteristics and uses of the C++ programming language, and I'll identify the main concepts behind its implementation. So let's start off by talking about its basic language characteristics. So variable types are statically typed, so they're checked at compile time, and you need to be specific about what a variable is used for, what its type is. This helps protect against accidental use, and it improves runtime overhead. So we have user-defined types that are central to C++, like classes, structs, unions, and templates. And C++ takes a balanced approach between elegant and affordable in terms of readability, maintainability, and efficiency. Now, you'll often hear people talk about C++ being cross-platform. The compiled result is not typically cross-platform, so we have a binary that's specific to a particular system, but the language operates at a degree of abstraction above the system. It's not an assembly language with processor-specific directives and registers. So compilers are written for just about every modern computing system imaginable, from low-powered smart cards and microcontrollers to PCs and GPUs and supercomputing clusters. Now, C++ is used in a wide variety of applications. It's not just specially built for one particular area of application. It's not like a SQL nor an assembly language. So there is a bend in C++ towards systems programming and direct hardware access, but that's not due to the language itself. It's more due to the connection to the C language historically, and its emphasis on low-cost or zero-cost abstractions. And also note that C++ is case-sensitive. So variable names with upper and lower case, if they spell the same name but have different upper and lower cases, they're different variables. Now you can write C++ procedurally just as you would C. Although you would miss much of its power, it's perfectly valid. C++ supports many approaches and styles, including procedural programming. You can do object-oriented programming, so you have it's modeled around objects instead of actions. So we have object hierarchies, encapsulation, inheritance, and polymorphism. So we have generic programming, so we have algorithms that are typed when they're instantiated. So methods that can operate on a variety of types, including C++ templates. So what are some of the cornerstones of object-oriented development in C++? Well, we have encapsulation, so we bind data with functions that manipulate it. So we have objects with constructors and destructors and operator overloading and basic member variables and functions. We have data hiding, so it hides the details of an object to other objects that derive from it. So we have things like public and private methods and protected access control. We have inheritance, so objects take on the properties of existing objects. So we extend the concept of a particular object into more specific refinements. And finally, we have polymorphism. So an object can take on many forms. So an object's implementation can share elements from a particular base class. As you see here, objects dog, cat, and bird share elements of the class animal. And in terms of interface, different derived classes can be used through their base classes interchangeably. So we can access a list of animals that are either dog, cats, or birds, but we access them through the animal object using their methods like move and speak. What are some C++ libraries and standards? Well, the core language of C++ are the C++ built-in types, operators, and statements. It has no built-in high-level objects or types or primitives in its core language, not the high-level stuff, just low-level built-in things. It just has the fundamentals of the language itself in the core language. But we get this defined, originally was defined in the ANSI standard C++ in the late 1980s, and then we developed into more high-level ideas that got included in the standard library, which is all written in C++. So this has containers, algorithms, and complex types, all provided in the C++ standard library. What was called the standard template library, or STL, became part of the C++ standard library in 1998, and this was the first ISO standard. C++ was originally created by Bjarne Stroustrup in 1979, and it started as C with classes, and then it was extended from there, only getting its C++ name in 1984. The ISO C++ standard was introduced in about 97 and finalized in 98, and by 2011 we got the ISO C++11 standard, which incidentally, after I began programming in C++ in the mid-1990s, and then moved away from C++ programming in the mid-2000s, I came back to C++ in about 2010 ahead of this standard, which reignited my own excitement for C++. Now we have further improvements with C++ 14 and C++ 17 ISO standards, adding new features to the language and standard libraries, but while maintaining its core concepts and design approaches. Now, C++ is a general-purpose language, so its use is wide. So we have software applications, many high-level software applications like major tools such as word processors, spreadsheets, and web browsers, email clients, and other major applications that we have on desktop computers are often written in C++, and many modern games are written in C++. We have devices and systems programming, so we create device drivers, device firmware itself, microcontrollers, even smart cards you use in your bank or credit cards. Because of the low-cost abstractions, C++ compiles down to an efficient implementation for many of these platforms. Then we have GUI applications for Mac, Windows, Linux, BSD, Unix, PCs, and workstations. So it's not just limited to a small subset of these. It's not a specific language that only works on a particular operating system or particular windowing platform. It's pretty much across the board. Now, if you use libraries for languages like Python or R for things like machine learning and data science, you'll often see many of its library implementations done in C++, and this is primarily for performance reasons. So many of the implementations for data science and machine learning use GPU libraries for performance reasons, which have interfaces that are written in C++. So you write a lot of the implementation code in Python or R, but the underlying libraries are written in C++. And that concludes this. Eclipse is a popular open source IDE, or integrated development environment, that can be used to develop for many languages, including Java, C, and C++. In this video, I'll present how to download and install Eclipse for C and C++ development. So if we go to the eclipse.org website and go to the download section, we can find our download for installing Eclipse. Now, if you need other information on Eclipse documentation and whatnot, you can get it from this website. Now, we go to the downloads, and it's going to recommend a location that's close to us. So it says my download file is here. So downloaded from Canada, and a particular host of the Eclipse install win64.exe. Or we can select another mirror and choose a location that may be more appropriate to us. Like if I want to download it from the University of Waterloo site. So all these mirrors give us close locations where we can download Eclipse. Now, I've already gone ahead and downloaded it before this, so we don't have to sit through the download process. So if I go to my downloads, you'll see the Eclipse install, Eclipse inst win64.exe. Now, before we install the IDE, before we install Eclipse, we need to install Java, either the JDK, which is important if you're doing Java development, or the JRE, the Java Runtime Environment, if you want to run Eclipse for other development, like C++. So I've also already downloaded the Java Runtime Environment. So I've downloaded let's get out of the menu here. I've already downloaded the Java SE Runtime Environment 8, and I've downloaded it for the 64-bit Windows. So I've downloaded this one, this JRE 8U144 Windows x64.exe. So if we look at my downloads, you'll see it here. So let's open the downloads folder, and we'll start out by installing the JRE. So that's the file right here, JRE 8U144 Windows x64. So I double click on this file, and we'll go through the install process. So I'm going to allow this to make changes on my computer because it's going to install the software. And now we'll just install it in the default location. So I'll click install and I'll let it do its thing. Now it's completed and it tells us we have successfully installed Java. So we'll close this. And now that Java is installed, we can go to our Eclipse installer. Our Eclipse installer here, Eclipse Inst Win64. So I'm installing it on Windows. Now, obviously, if you have a different platform, you can choose the appropriate installers and it will work just the same. Eclipse runs across many platforms, including Windows and Linux and Mac. So if you're running on a different system, then just download the appropriate installers and it should work just the same. So I've double-clicked on the Eclipse installer. Now that the Eclipse installer is open, it gives us some choices. The Eclipse IDE for Java developers, for Java EE developers, C++ developers, etc. Of course, in this video, we're focusing on C and C++, so we're going to install this particular Eclipse IDE for C and C++ developers. And we're just going to give it the default installation. I'll do an install, and we'll let it create a desktop shortcut and a start menu entry. Now you can read this user agreement and click Accept Now, and it will carry out the installation. Okay, now that we've launched the installer, one thing I recommend doing before you proceed is going to this menu here, this hamburger menu, and if there's an update available, you'd see it here in this menu, and you can click Update, and that will update the installer to the very latest version before you continue with the install. Now, in this case, I've already done it, so you can go to, once you've done that, you go and select the Eclipse IDE for C, C++ developers, and click on that, and do the install. You can select the version whether you want 32 or 64-bit, depending on your system. In this case, I want the 64-bit version. It'll ask the location of your Java runtime environment, your JRE, which it's found it here in Program Files, Java JRE, the one I've just downloaded, and then it gives an install location. So I've clicked install, and it's going to carry out the install process. Now that the installation is completed, we just click the launch button, and we can launch Eclipse for the first time. It'll ask us on the first run, it'll ask us where to put the Eclipse workspace, and I'm just going to use this as the default and not ask again, and click launch. And now we've launched Eclipse. We can click it to maximize it, and we get a welcome screen with some information about Eclipse with tutorials and samples and the ability to create new C and C++ projects. Now, the installation may have been a bit slow, but once it's installed and you're up and running and launch Eclipse for the first time, you're ready to start developing. And that concludes this demonstration on downloading and installing the Eclipse. Eclipse is an open source IDE for developing applications with different programming languages, such as Java, C, C++, and PHP. In this video, I'll explain how to create a new Eclipse project. Now in this video, we're going to look at creating a new C++ project. Now, if you've just installed Eclipse and you still show the welcome screen, you can always turn it off, and quite often people do turn it off. But if you do have it up, you can go select from the list, create a new C++ project. Now you click it and it will bring up your create project dialog. Now equivalently, you can go up to the file menu and select file new and hover over new, and it will give you a list of different types of projects you can create. Now I'm going to select C++ project. Now if you want to get to this quicker, you can always use the Alt-Shift-N shortcut and bring it up immediately. So there's a nice shortcut key. You can get to it quicker if you're creating a project, or you can just select File New and C++ Project. I'm going to call this project just Example 1. I can select the location of it. The default location is in the Eclipse workspace directory, and under the name of the project, so example 1. You can select a project type. For this, I'm going to select an executable Hello World C++ project. So it's going to give me a basic boilerplate C++ project. And I'm going to select the cross-compiled GCC as my toolchain. So the toolchain is basically the compiler or compiler and linker, whatever tools that surround building your C++ project. Now I'll click Next. And it has some information here. The author I can put in. These are all these are non-mandatory settings. I can just skip over, and I can select the configurations, debug, or release. I'll just leave them both selected. And I can put in some information about the GCC compiler. So I need to select where it's stored on the system. And then once I've selected the compiler, this cross GCC command for compiling, I can hit finish and it will create the project. Now, once I've finished creating it, I need to bring it up. So I need to go over to the menu and bring up some information about my project. Now, I might just want to close the welcome screen. Let's close this, and we can see our project. Now, there's a few errors here because I haven't set up the compiler, so it doesn't know where the G++ compiler. So this, on a fresh install of Eclipse, it expects the C++ compiler to be already installed in the system. As such, I cannot compile using Eclipse for this example anyway. And that concludes this demonstration on creating a new project with Eclipse. The GNU Compiler Collection, or GCC, are tools and configuration options that you can use to compile and link C++ programs from the command line. In this video, I'll demonstrate how to use the GNU C++ compiler, or GCC, to compile an executable file from the command line. I'll be demonstrating this on an Ubuntu server install, so I'll use Ubuntu-centric methods to install the GNU Compiler Collection. That is, I'll install it using apt. Other Linux systems, BSDs, Unixes have similar methods of installing using the system-appropriate package managers. So I'm going to use the apt package manager, so I need to run it using root. So I'll need to do a sudo apt install, and I want to provide the build essential, which will install the GNU Compiler Collection along with some other basic tools for compiling, for building on a Ubuntu system. I also like installing an editor. Instead of using the built-in VI or Vim, I like to use the Emacs 24NoX, so I have a terminal-appropriate install of Emacs. That's what I'll use for an editor. So I'll run this install, and it's going to install the packages I need and a few of the tools, including Emacs. And when it completes, we can create a small C++ program and test out the compiler. So now that it's completed, I'll type clear my screen from all the information from the install. And now let's test our GCC. So one thing you can do is just do GCC space hyphen version. And that will give us the version, or GCC, double hyphen version. So make sure you get the two hyphens in there, GCC double hyphen version. And that tells me the version of GCC I'm running on this version of Ubuntu, this 16.04, and GCC version 5.4.0. So let me clear this again so we don't have all this info showing. And we can create a very simple C++ application. So I'll do Emacs, and I'll call this hello world.cpp. So I'm going to do a few simple things. I'm not going to talk about too much about what I'm going to do. I'll do an include on Iostream, and then I'll do using namespace std for standard, and I'll do int main, and then just a cout of hello world. And I'll put a carriage return in the end, close it with a semicolon, and close our main function. Now I'll save it, close it. Now I'll do clear, again, to clear the info from the Emacs editor. Now we can do g++ hello world.cpp. And now let's look and see what it's created. So what it's done, it's compiled hello world.cpp and compiled the output into a file called a.out. Now it just uses this default one because we didn't specify anyone. So if I type a.out, it runs hello world. Now if we'd like to specify the output, we could do g++ hello world.cpp, and we can just call this program, so we just give it -o and then hw for hello world. Now if we look in the directory, we see that there's a new compiled binary hw, and if we run it, h./hw, it prints our hello world message. Now there's a few other common options that you should be aware of right off the bat. One is g++, so -WALL for W all. So this is the warnings option. So this will output all compiler warnings. So let's do hello world, and we'll overwrite our HW. So hello world.cpp -o HW. So there were no warnings, and it compiled fine. Another thing you can do is include debug symbols. So you want to be able to debug your code, say using the GNU debugger. Well, to do that, you need to have debug symbols. So to have that information when you compile, so if you want to compile it in debug mode, do a -g, and then compile it as usual. And now if we look in the directory, you'll see now one interesting thing. So you'll see here, this version of HW is 20,000 bytes for a very simple compile. If I compile it without the -g switch, let's compile it again and check in the directory using ls-la so we can see the size. It's only 9,056. So when you compile it for debug using -g, your output size will be much larger because it's included all the information to debug your code line by line. If you omit the -g, it doesn't need to include that information, and your output binary is smaller. And that concludes this introduction to the GNU compiler collection to compile C++ programs on Linux. In this video, I'll demonstrate how to set up a new C++ project in Visual Studio, how to switch between solutions with multiple projects, and how to run and debug projects. So we've started out here with our Get Started start page. So when you launch Visual Studio Professional Edition for the first time, you'll see this page. You'll also get developer news from Microsoft in here, and you can easily expand or hide it with this arrow if you don't want to see it. We have a few options here when it comes to projects. If you have existing projects, you can open them right from this start page or create a new project. You can also access these functions from the menu if you set Visual Studio not to show the start page when it first loads. That's fine. If you have any recent projects, they'll show up here as well. I'm doing this demo on a fairly fresh install of Visual Studio. The only time I've run it before is to set up a few of the options, such as the font size that I'd like to have in my Visual Studio. So this is literally the second time I've run Visual Studio on this fresh install. So let's start off by creating a new project. So I'm just going to go on the start page and click the Create New Project link. So it'll take a second to bring up a dialog that will guide me through setting up a new project. So it's the first time, so it's a little bit slower to initialize. But once you've done it it is a little bit quicker. So it gives me some options of the different types of projects: Visual C#, Visual Basic, Visual C++, JavaScript. Now, since we're doing Visual C++, I'm going to hide the Visual C#, open Visual C++, and let's look at the General tab. And so we can do an empty project, a makefile project. There's some different Windows Desktop, Windows Universal. So let's just look at the different ones: ATL project and test. So what I think I'd like to do is create an empty project. So I'll just leave the name project 1 and click OK. So that should create a new file, a new project with the appropriate files. Now it's successfully created the project. I have it over here. Now I can right click on the project and do some things like build it, which won't do very much right now because there is very little in it. There's nothing in it. So we can just leave that here, and we can go to our source files and we can go add a new item. Let's just add a new item. And it's going to give us some options. I want to create a CPP file. Let's just call it source.cpp. Just leave the defaults in for this example project. And it should include my file, bring up the code, and I'll just do int main, and that's it. We could leave it empty. We could put in a message. Let's just leave it empty. Save the file. I just did a Control-S to save it using the shortcut key. Now, another thing you can do to build it, you can do a Control-F7 to compile it, or you can go up to your build menu and say build solution. So there's a few options on how to build it or build projects. Now we have a solution here. You see in the Solution Explorer, we have a solution, project 1. So solutions we can have multiple solutions in here, but we can also have solutions with multiple projects. Now you'll see here, the build has been successful. If we look in the output window, build 1 succeeded. So everything seems to work fine. Now we could go to some other menus. We could debug it. So we could do F5 to start debugging, or we can select it from the menu, and it will run it in debug mode, and it will recompile it if it needs to when we click run in debug. So if you've made any changes, it will pick up those changes, recompile, and then run it in debug mode. Now it does show me some extra information when I do run it in debug mode, and it just ran it. There was no breakpoint, so it just ran it, and then it exited because the program does nothing. It just launches and then it returns, and that's it. Now let's add another project. So let's do a file, new project, and we'll create another empty project. So this one will just be called project 2. Click OK. And you'll see we have solution project 2, but we no longer have project 1. So that's been closed. So we have our Solution Explorer here. And what we can do is add another solution or existing project and select the project 1. It's going to go into so we go to project 1 and we select the project file and open. So we have a solution here with 2 projects. So we have project 2 and project 1. If I double click on project 1 or right click and say set as startup project, or I can select to build this particular project separately, or I can select scope to this and it will scope to this particular solution, or I can go back. So you can navigate your projects and solutions here in the Solution Explorer and pick which one you'd like to compile or run. You can hide and show them and set them active depending on which one you're working with. So it won't necessarily build all of the projects, just the one you've selected on. So I can say build or rebuild. So it's building project 1. If I right click on project 2 and say build, it will build project 2. So those are some of the things you can do with adding projects and switching between projects with Visual Studio. And that concludes this demonstration on C++ projects in Visual Studio. In this video, I'll break down the elements of a C++ program. So first, every program needs an entry point. In some languages, like Python, it just starts executing the file that you execute. It starts interpreting it from the first level, whatever code it sees, it executes. But in C++, we need a main function. So this is the entry point to any C++ program. So you cannot call main from anywhere else within your program, not from main itself recursively, definitely not, and not from any other function you define. So main is only called as an entry point from the operating system or whatever calling procedure calls your program. It calls the main function. So even if in this case we define it as int main, so this is the simplest way we can define main. If we have any command line arguments that we'd like to pass, which I won't get into in this video, it goes as function arguments in these parentheses. And then we have the code block itself. So it starts with a brace and ends with a brace. So this defines the statements, the body of the function for main. And it's declared to return int, but main has a special status in C++. If there's no return in it, it implicitly returns 0, which means success. So if it reaches the end of the function block and doesn't see return 0, it returns it implicitly. So you don't explicitly have to provide it, but you can if you want. If you're used to seeing it that way or for legacy reasons, it's fine to have it, but it's also fine to leave it out. So as I've declared main here, this is the simplest C++ program possible. Now let's expand it a little bit. So we often need to bring in function prototypes or declarations from other files. So what we do is we include them. We do this by using a hash or pound sign or number sign include, and then we open up these less than greater than symbols. So this encapsulates what we're going to include, and I'm going to include Iostream. So this comes from the standard library. So this is a standard input-output stream library provided in C++. So this gives us access to functions to input and output things. Mainly, we use it in simple programs, we use it for the cout function. So we do standard std : so this defines the namespace the function comes from, the function cout, a double less than operator, and then the string we'd like to output. So the strings are in double quotes, and then we end each statement, each line of code, with a semicolon. Now, we could put multiple statements on a single line, but it's typical practice in most cases, to have each statement on a line, and we must end each of these statements with a semicolon. So we've included the Iostream library, which gives us access to this standard namespace std, which we specify with std : the function cout, an operator that the function takes, that this object cout takes, which is the double less than symbol, and then some string in double quotes. So this is a typical first example hello world of a C++ program. Now, a couple other things I'd like to mention about program structure in C++. Comments. Single line comments begin with a double slash, so this is a single line comment. And we can do multiple comments if we want to have, all these lines as comments. But more simply, we can have multi-line comments. So if I leave that single line comment, I'll start a double or a multi-line comment with a slash %, slash star, and then star slash to end it. So anything between the slash star and star slash is a multi-line comment. So I can put some comments in here. This is comment. And I'll shorten it. And you'll notice there's a little box here with a line in it next to this comment and also next to this function. So one of the features of Visual Studio is that you can collapse these multi-line comments and functions. So I can collapse the comment, collapse the function. If I have a lot of code in there I'd like to hide, I don't want to visually look at it, I can collapse it so I can see what I'm focusing on a little bit easier. So it provides this feature to collapse and expand these blocks, either blocks of comments or functions. So that's a very basic structure for an initial C++ program. The last thing that remains is to compile and run it to make sure we've done everything correctly. In Visual Studio, you can go up to the debug menu and select however you'd like to run it. So start debugging or start without debugging. We're going to start it without debugging. Now, you might have seen briefly in the menu, so debug, and we go down to start without debugging. Or more often, you'd want to use the shortcut key, this Control plus F5 is the default. So if I'm here in my code and I make a few changes, what I'd like to do is run it. I just press Control F5. And then if it needs to build it, it will prompt me, and I click yes. Or I can not show it again and just have it build automatically, which I think I might do, is how I usually set it up myself. Click yes, and it's building the project, and then it will run it. Now it's a command line program, so it launches this command window with the output of my program. So I have hello world as I wrote it in the cout statement, and then it says press any key to continue. And then I just hit any key, and it closes the command line window, the terminal window, and it brings me back to my code. And here in the output at the bottom, when you build something, it shows the compilation information and whether the build was successful or not. And that concludes this demonstration on C++ program structure. C and C++ have some similarities. You use a similar program structure and some of the same essential syntax, but there are many differences. In this video, I'll cover some of the basic differences between C and C++. So the first obvious difference is that C++ has true classes. So these are user-defined type representations that have tightly coupled functions and operators, which we don't have in C. In C, we have objects called structs, which don't have member functions. So here we have a class, a user-defined type in C++ called myClass. Class members have attribute visibility, such as public and private. So public members are accessible to anyone who instantiates a class, and private members are only accessible. These are variables that are only accessible within class members themselves. So these member functions, like the constructor, the myClass constructor, and the tilde myClass destructor, where we initialize and deinitialize or clean up our classes when we're done with them. And then we have member functions like this myFunction, and classes can also have virtual functions and overloaded operators. So the C++ class is a powerful tool with many qualities. On the other hand, C is object-based. So C has structs, which have member variables, and that's it. Like this struct myStruct, which has an int a and a char b. And that's it. So the power of C comes not from how comprehensive these objects are, but it comes from the functions defined to manipulate its objects. Now in C++, we also have structs, but it's just a class whose members are public by default. Enumerations is another difference between C++ and C. So in C++, enumerations are scoped and strongly typed. They can be statically cast to ints, but they're not assignable to ints implicitly, like in C. So in C++, we typically use enumerations called enum classes. Although it does have C-style enumerations, the preferred method now is to use an enum class. Whereas in C, we often typedef our enums. So we have this typedef enum, and then some definition here with our enums of false and true. That's of the typedef boolean. Now, one thing to mention here about this boolean enum, which we may have done in C previously, the bool type is a fundamental type in C++, which can take on values like true and false. Now, the enum class, like the enum class size here, these objects are not particularly considered ints by default, or we can't access them that way, because these enumerations, these enum classes, are checked at compile time. Now, one similarity between C and C++ is that they both rely on the main function as their entry point, and their main functions are defined equivalently. So the main function you'll see in C and C++ programs. Now, assigning or allocating memory dynamically is very different between C and C++. In C++, we have the new operator, so we take this char star s and we make it equal to a new char, and we specify the size. In this case, we use this array syntax, so we have the bracket 100 close bracket, and that assigns an array, or assigns 100 characters, or allocates space for 100 characters that can be addressed by this char star s. And then we have a pointer to t, this char pointer t or char star t in the C style, which we use malloc. So here we cast it to a char star, which may or may not be required by your compiler. We do a malloc, we specify the size. In this case, we want 100 elements of size char. So this is the space we set aside. Now in C++, it infers that from what we've expressed here. But in C, we have to specify the size in this call to malloc. Now how we clean it up is different as well. So in C++, we allocate with new, and we clean it up or free it with delete. Since we've allocated it using this bracket syntax with 100, we delete it using the double brackets here at the end of delete, and then our variable name. And then in C, we just call the function free. So we call free, give it our variable. Now, one thing to make absolutely sure is that you should never mix these in your program, and never try to free something you've assigned with new using the C style free function. And if you've done a malloc to allocate something, never try to clean it up with delete. They won't work. And then finally, one of the other differences is just basically how we output to a console window or to some output stream when we're outputting strings in our program. In this case, the C++ style is to use the cout. So we have std : from the standard library. Using cout, we give it this double less than operator, which in C would be the left shift operator, but here we've overloaded it to take a string, and we give it this hello world string. So this is the C++ way of doing it with cout. And in C, we typically rely on the printf function. So we do a printf and give it the string that we'd like to print. Now I'll mention a couple of more differences. One is dealing with parameterized types. In C, this often involves function pointers or void pointers to deal with different types. So things that can operate equally on, say, ints or doubles or any numeric value. So we do this in C often without compile time checks, and occasionally we use different implementations for each type that we're dealing with. In C++, we use templates. So we get function templates and object templates that do get checked at compile time. And finally, one last major difference, which I won't highlight, is exception handling. In C++, we have proper exception handling where we can throw and catch exceptions using try and catch. But in C, we don't have that mechanism. Errors are caught by inspecting return values from functions or looking at return codes from functions, or by checking if a global error value has been set somewhere. So there are many other differences, but these are the most obvious and frequent ones we come across. And that concludes this demonstration on some basic C++ syntax differences. In this video, I'll demonstrate how to work with two basic IO streams of cout and cn, and how to use them to read and write formatted character streams from the console. So our program will start off by including our string library, because we're going to use a string, and our IO stream, which is what we're talking about in this video. Now, to keep things a little bit simpler in terms of typing, I'm using namespace std for our standard namespace, so I don't have to type it everywhere. And now in our main function, let's look at what our code's going to do. So I start off by using the cout output stream from the Iostream library that we've included. So cout has an operator, this C-style left shift operator, so the double less than symbol, and then it takes whatever string or whatever object that we want to output as a character string or character stream to our console. So in this case, hello, comma, space, world. Now, note that carriage returns or end of lines are not inserted automatically by cout, and we have to insert them manually. So that's why I have this \n here. So that will carriage return on the console to the next line. And then I do a cout on hello, comma, space. And then I give it another left shift operator, another double less than symbol, and output the string world, exclamation mark. And then another operator, and then end L for end line. So this is synonymous with \n, so I can just type it as this end L or I could change this to the string double quotes \n double quotes. So those would be the same thing. So let me put it back to the way it was. So those are two ways of carrying out the end of line or carriage return. Now I'm going to initialize three variables, an int called intval, a double called doubleval, and a string called str. So these are going to take the inputs of our cin. So we have a cout that prompts us what to enter, so enter an integer, :space, and then we have our cin, which takes the intval, and then we do the same thing for the doubleval and the string str. So the cin looks for input and formats it into the variable that we specify. So we'll get enter an integer, we'll type a number and hit enter, and then cin will put the value that we entered into this variable. Now down here on line 23, near the end, the penultimate line before the return, we have our cout, uentered, and then we give it our operator, intval, the operator again, another string, so that we have this formatted output here, our doubleval, comma, our str for our string, and then finally our end line or end L. So let's run the code. I'm going to type a Control F5. That will compile and run our code, and we should get a console window. So we have our first two lines outputted, our hello worlds. Now you'll notice the first one I didn't put an exclamation mark in, and the second one appears on the second line because of the carriage return, this \n, and the hello world here, it outputs just fine, even when we separate it using the cout operators. And now we have enter an integer. So I'm going to enter 10, and then enter a double, say 1.1, and some string, let's just write the word test. And then we get you entered 10, 1.1, and test. So that's pretty much as expected. Now there's some ways to format output and redirect output to other output streams like the cerr output. So the cerr is another alternative to cout. Instead of putting to our standard output, it puts it to the standard error as determined by the environment or the OS we're working in. And that concludes this demonstration. The C++ preprocessor allows you to run code and apply definitions in a pre-compilation step. In this video, I'll demonstrate how to use the C++ preprocessor to declare constants, constant expressions, and preprocessor macros. So the contemporary wisdom with regards to using C-style macros, like your typical defines, is don't use them unless you have to, at least not in the old way. So avoid them if you can. So what you want to use is consts or const expressions instead of C-style preprocessor macros. So if you're using C++, prefer to use const expressions. Now, when you should still use defines, most often you'll see them as include guards. So this is something that you will see quite often. Now, in this case, I'm using Microsoft Visual Studio, and it uses as an include guard the pragma preprocessor directive. So you'll see this is not a portable way of doing this, but this is a very common industry-wide standard that's used as an include guard. So it's called pragma once. So when you add a header to a project in Visual Studio, it adds the pragma once directive to it automatically. So what this does when you add a header to a file, or if you include it in many files, it only gets processed once. So that saves the compiler much work, and it speeds things up, and it makes sense that you access a header file from multiple source files, but you only process it once. So that's what the pragma once directive tells it. So it's an include guard to make sure that the code inside of it only gets processed once. Now, I say it's non-portable, so it's not always portable, but major compilers like Visual Studio and GCC or Clang, they all support this pragma once directive. Now, if you didn't have this, what you'd want to do is include an include guard using a preprocessor macro. So you'll have something like if not defined or if ndef, and we give it, let's see, std afx h, you'll see something like this. and then we'll do define xh, and then down at the bottom, we'll have endif. So what this does, it says that if we've not defined this std_afx_h, then define it, the code gets processed, and then we get endif. So the next time our compiler sees this file, it will see that it has been defined on the previous include, so we don't need to process the contents again. So that's one preprocessor macro that you should be aware of and that you'll see come up very often. And you won't always see, you'll either see this or the pragma once directive that I erased previously. So we'll just leave it like this, that should be fine, and we'll go back to our source file. So I mentioned the const expression. So this is something that's available in C++ 11 or later, and it allows you to declare typed expressions. So this is not the best way to define pi. I'm only doing this for example. So we have const expr double pi equals some pi to some fixed number of decimal places. So we use const and/or const expression to assign values to symbolic names. So this gets processed by the preprocessor. So it's done at compile time. It's not something that's evaluated at runtime. So you do get this evaluated at compile time. And now we'll go to our C-style preprocessor macro using hash define or number sign define. And I define a function or this macro function called radians, which takes a variable called deg for degrees. Now you'll notice none of this is typed. So there's no return type. There's no type on my input value, and I'm accessing these values without much indication of so this doesn't look like C++ code. So if we can have a preprocessor macro language that uses C++ code, surely it should be preferable. But it does support this, and you can still define macros this way, but it's not recommended if you have C++ 11 or later. If you have const expressions, you probably shouldn't do it like this. But, and you know, there's no return statement here, so we don't say we're returning this value. We're just putting this value in, this expression in, and we expect the compiler to know what to do with it. So here's the same thing done, the same conversion, the same function done using the C++ style const expression. So we have const expression, const expr, the return type double, and I'll call this one to differentiate it deg to rad for degrees to radians. And it takes a const double d. So we type our input variable, our argument to this const expression, and then we return using standard C++ code, d times pi divided by 180. So that looks like normal C++ code, except that it's qualified as a const expression. Now let's get into the main body of our code. I want to show a few of the things you should be aware of when using const expressions. Now, if I declare a volatile variable, this double d1, set it to some value, and I try to use it in a const expression, I'll get an error. So if we go down a few lines to line 21, you'll see I have const expression double d4 equals d1, our volatile variable times 42. So there's a little IntelliSense error underneath the d1 because it's a volatile variable, and I can't mix volatile variables with const expressions. But the same applies for regular const. So if I have const double d2, and I try to use that in a const expression, I also get an error. What I need to do is declare the variable as a const expression so that I can mix it with other const expressions. So assigning a const expression to another or using it in a computation with another is okay. And all of this gets done at compile time. Now I've declared two more, const expression double dx equals deg to rad with the value 42 as the degrees, and it will return the radians. So this will get processed and evaluated during compilation. But I can also do this using a regular define. So radians is defined using a C-style define preprocessor macro, and I can assign it to a const expression. So that's okay. It's not ideal, and I'd recommend doing it this first way, but you can do it that way if you need to. If you're mixing modern code with legacy code that you have, where you do have macros defined using the older style preprocessor macros. Now, a couple other things before I run the code and before I wrap up this demonstration, let's look at a couple of standard predefined macros, namely file, line, time, and date. So you have these predefined ones that have this double underscore prefix, the name, in this case file, and the double underscore suffix. So file will give us the current source file, the line number, in this case 28, and we can get the compile time and the compile date. So let's run the code and we'll check this these couts. And you can see here in this output, it shows the source file, where it's located, the full path of it, and the Cpp file, and the line it's on, 28 as expected, and it was compiled at this time on this date. And I'll press any key to continue. And that concludes this demonstration on the user to change a command line program's behavior using arguments passed to the main function. In this video, I'll present how to parse command line arguments in C++. So let me run through some example code I've created to demonstrate how to parse these command line arguments. So I'm starting with the typical standard library includes Iostream for cout and cerr, and string, so we can parse the command line arguments as a string. So to keep things simple for this video, I'm just going to bring in the full namespace for the standard library to save a little bit of typing, so we're using namespace std. And now let's look at our main function. So our main function takes two parameters, int argc and char star argv, double bracket. So our argc is short for argument count, and our argv is short for argument values or vector. So the v is, I always think of it as argument values, but some call it the argument vector. So, but it's just an array of character strings representing the command line arguments that you pass to the program. Now, what we usually do is have some sort of notification if the usage is invalid. So if you pass command line arguments to your main function from the command line, so if you type the name of the program and a space, and then you type one argument, space another argument, and then you can pass multiple arguments. You've probably done this many times from the command line. If we pass the wrong number of arguments, we want to show an error. So obviously the person invoking the program has given the wrong number of arguments or has given too many arguments. So we typically check, okay, if we've gotten too many arguments, in this case, if the argument count or argc is less than 3, then we don't have enough arguments. So what we can share is how to use this program, what it's expecting. So the usage, so typically we say cerr, and we provide a usage for the program name. So one of the things, the argv doesn't just contain the arguments we pass, it contains the name of the program invoked. So argv0 is always the name of the program. So we say the usage for this program of this name, so argv at 0, so argv and array index 0, and then we say it's expecting an option followed by a file. So one of the options are ~find. So this is, we want to find the file specified, and ~display. We want to display the file or the contents of the file. So this is just a simple example. So what we typically do is say, okay, if the arguments aren't correct, we return 1, but we also give some conventions on the usage of the program. So we can direct the user how to use it. So if that succeeds, if we have the correct number of arguments, if we have 2 arguments, then we take argv1, which is one of the options, so find or ~find or ~display. We want to set this or pass this to a string. So we're taking a char star, so a character string or an array of characters, to a string. So we're using the standard library string so we can compare it more easily. So since it's arg is a standard library string, we can do a double equals comparison, and we can check to see if it's double hyphen find, and we'll just see out that we've specified the find option. Else if arg is equal to double hyphen display, we see out the display option. And if the argument is neither of these, we just say invalid option. So this is a very simple way of checking a particular command line argument. And then finally, we see out the file argument at argv2. So if you look at the way these are indexed, argv0 is the program name, argv1 is the first argument, and argv2 is the second argument. So it's a very simple way of thinking of it as the arguments themselves are 1-based indexes because the 0-based one is always reserved for the program name. Now I'll show you how to do this in Microsoft Visual Studio. So when we pressed our shortcut key, our Control F5 to run the program, there's no way of specifying the command line arguments before it runs. So if I just hit Control F5, it will run the program. But before we do that, we'd like to check our command line arguments. So if I go to Debug and Properties, and we want to go to Debugging, so Configuration Properties, Debugging for our project, for our solution, and we want to go to Command Arguments. So in this case, I've already set it to _delete file.txt. So this is a way of checking one of the options. This particular argument doesn't exist, so we'll get the invalid branch of our conditional, so it's an invalid option. But let's check our correct option. So I'm going to do _find file.txt. So I'll hit OK, and now I'll do a Control F5, and it will run the program. It'll compile it first and then run the program, and we should see the find option with the file. So it says find option as expected, and then the file argument is file.txt. Now let's change that again. So we'll go to the properties and debugging, and let's change this to _display, and let's call this another file.txt. So I'll hit OK, hit Control F5 again, the shortcut key to run it, and we get display option, file argument, another file.txt. Now, it came up a little bit quicker that time because it didn't have to recompile the code. We only changed the command line arguments, so that doesn't change the program itself. So it doesn't need to recompile for each of these options we're changing, because this is passed externally to the program after it's compiled. And my other example, _delete, which does not exist, and let's just call this file2.txt for lack of a better example, and we'll do Control F5 again, and you'll see invalid option because _delete isn't an option that we check for, and we have file argument file2.txt. Now, one more thing to check. What if we hand it the wrong number of arguments or too few arguments? So let's go to debugging. Let's remove these command line arguments and run it this way so we can see the error. And you'll see usage shows the entire path of the executable. So it has the entire path and the name of the file, 130.511.exe, option file, and then it shows _find the file, and _display, display the file. So it shows the usage that it expects when we don't specify the number of arguments. Now, one more thing I'll mention. We've done this by hand, so there's a lot of work involved in making this robust and processing many different types of arguments and different types of switches with double hyphens, or some commands take a single hyphen and a single character. So what I've shown here are the basics of command line arguments. If you need something more robust and comprehensive, you can imagine there are a number of third-party utilities which you can use if you don't want to write your own. So two of the more prominent tools, I'll switch over to my web browser, So two of the more prominent tools, one is the GNU getopt from the GNU libc library. So I've shown this here. So if you look for the GNU libc in the documentation, you'll find a parsing program options using getopt. So getopt are functions to make, it says right here, getopt and getopt-long functions automate some of the chore involved in parsing typical Unix command line options. So this will simplify things for you if you use these functions. Another option in C++ is using the Boost program options library. So switch over to the other tab, and at boost.org you can see in the documentations, you look for program_options, and you'll see a C++ library to do the same thing. And that concludes this demonstration on command line arguments in C++. In C++, you can break your code out into a series of source and header files to make working with large applications more manageable, portable, and modular. In this video, I'll demonstrate how to divide the code into header and source file pairs, and to divide code between declaration and implementation. So in this program, I include two headers, Iostream and x.h. Now you'll notice that they are enclosed in different characters. In Iostream, we have it surrounded by angle brackets, and x.h is surrounded by double quotes. So we use angle brackets for standard library includes. So things that come from the C++ standard library, we put angle brackets around. And header files that come from our local project, is something that's included in our project or relative to the local path, something in the current directory, we use double quotes. So this is a custom implementation, and this is a standard library implementation. So Iostream, angle brackets, standard library, double quotes, our own local declaration or header file. Now, a couple of things. You don't want to include other source files in your application, so you don't want to include x.cpp. You only want to include header files, and the includes come before other code in your application. So if we have implementation code, the header files always come first. And also, only include headers if they're needed. Don't include all of your headers in each CPP file just in case you need them. This will not scale well and slow down your compile times. Now let's have a look at our implementation x.h. So we can look at our Solution Explorer here in Visual Studio, and if we double click on x.h, it'll open up this header file. So the header file contains a couple of things that are common to most header files. The first is the include guard. Now there's a couple of different types of include guards, which I won't get into in detail, but this one uses pragma once. So you'll see this at the top of many header files that you include in your application. And in Visual Studio, when you create a new header file, it will automatically put that in. And many header files have namespaces. So we have namespace EG to differentiate our class X from other classes from other headers that may be called class X. So we have namespace EG, and then we have class X. So an uppercase X is our class name. It has some public members, including a constructor, and two member functions, getVal and setVal. Now, you'll notice in this case, the constructor, very simple constructor, just sets the value, this member variable value equal to 1. So we actually implement our constructor here, which is fine, but we don't implement these functions in the header file, this getVal and setVal. So we just have the declaration of the function, but not the implementation. That's saved for our CPP file. And then we have a private member int value. So it's a very simple class with a very simple namespace in this header file. So it has a source file companion or pair, so we have x.h, which implements the class X, and we have x.cpp in our source files that implements our member functions. So the CPP file must include the corresponding header file, so include, and in double quotes, x.h. Then we implement getVal just to return the member variable value, and we implement setVal to set the member variable value to what parameter, this int I, we pass to it. Now you'll notice here it's scoped with the namespace and the class name. So this is very important. If there's a namespace, we have to specify it first. then the class name, and we have the double colons in between each one. So e.g. :x :get val. So that's our source and header file pair for x.cpp and x.h. Now let's go back to our main CPP file and have a look at what we're doing. Now when we're including many header files and using particular objects from those header files, what we quite often like to do is use the using keyword, so using, and then we specify the namespace, :, and the object we're going to use, this class or struct that we're going to use. So in this case, from the standard library from Iostream, we're only using cout, so I'm specifying using std : cout, and from x.h we're using the x class from the eg namespace, so using eg : x. Now, quite often with simple programs and including standard library definitions, we do something like using namespace std. But that's pretty broad, and in practice, you want to specify what you're using and not just use an entire namespace if you don't have to. So in our main program, we have uppercase X, our class name, which comes from our x.h header, and the lowercase x here, the variable name. So we're initializing class X as variable x, lowercase x, and then the next line we have x, lowercase x dot set val, so calling the member function, and we pass this constant number 20. So we're setting the value to 20, and then the following line we do a cout, we output the string x value : and then the actual value calling x.getVal, and then we return the line. So let's run the program and verify that when we do call this, the output is x value : 20, which is what we'd expect based on the previous line. So we get x value 20 in the output. Now, this is a multiple header approach, so having x.cpp and x.h to organize declaration and implementation. This is what I use by default when writing C++ programs, even for simple programs, just for the sake of consistency. So I like to take this is an approach that I take in all of my programs, even for simple ones. If your program grows, then it's easier to manage, and it generally will compile faster if you take this multiple header approach. And that concludes this demonstration on headers and sources. In this exercise, you'll first list the identifying characteristics of the C++ programming language, then identify the main sections of a C++ program, and finally describe the use of the C++ preprocessor. So now you can pause the video and consider these bullet points, consider these exercise items, write down some of the answers or think of them, and then when you've completed the exercise, you can resume the video and I'll share what I came up with. So for the identifying characteristics of the C++ programming language, what I came up with is that it's statically typed, it's a compiled language, it's general purpose, and it's case sensitive. C++ supports many approaches and styles. It incorporates procedural, object-oriented, and generic programming, and C++ takes a balanced approach between elegant and affordable, so in terms of readability, maintainability, and efficiency. And because of the no-cost or zero-cost or low-cost abstractions, C++ compiles down to an efficient implementation for many platforms. It's a very performant language. So that covers the first bullet point. Now, for the main sections of a C++ program and the C++ preprocessor, I've written a bit of code to go through this. So we'll turn over to Microsoft Visual Studio, and right here I have a small program. And let's talk about the main sections. So some of the important points or the important parts of the C++ program are the includes. So we include header files from other sources, either from the standard library we have here, like Iostream, surrounded in angle brackets, and including some local header file surrounded in double quotes. We have things like using or using namespaces. We have Const Expressions or other functions declared in our program. And probably the most important part of a C++ program some component that you can't live without or you can't compile without is the main function. So every C++ program needs an entry point. And that's the main function, which always returns int and optionally takes arguments like int argc and char star argv. So this is the command line arguments, the way of passing command line arguments to our main function. And this is optional. But the main function is not optional and it must return int. So at the end of it, we have a return 0. Another thing is if it returns anything other than 0, it's sort of an abnormal termination. So returning 0 says that our program exited successfully or it completed successfully. If we leave off the return, so if we delete it, that's fine as well because the main function is special in C++. And it implicitly returns 0 if it reaches the end without returning beforehand. But it's fine just to put in return 0 if you like having it. Now the C++ preprocessor, one of the main things in C++ since C++ 11 or later, so in contemporary C++, we use Const Expressions. So these are things that are implemented by the compiler and are evaluated by the compiler and not evaluated at runtime. So when we talk about the preprocessor, we're talking about things that are done at compile time and not at runtime. And the nice thing about Const Expressions over the previous C-style preprocessor macros using defines is that we can specify types. So they're type-checked preprocessor definitions. So in this case, we have const expression double that I call C2F, which is a conversion function from Celsius to Fahrenheit. And this one takes a double C as an argument and returns the Fahrenheit conversion of this value in Celsius. So C times 9/5 plus 32 converts the value from Celsius to Fahrenheit degrees. And in the main function, the body of the function, all functions in C++ are enclosed in curly braces. So these curly brackets or braces define the function body. And then we have a const expression double in this case to demonstrate a preprocessor variable using const expression. So C is set to 33.0. And then we have const expression double F, which is the Fahrenheit equivalent, which C2F C. Now you'll notice here in Visual Studio, if I hover over F, it actually gives me the conversion. So 33 times 9/5 plus 32, it actually carries out this function for me right now before I compile it. So it shows me that the value for F will be 91.4. So we have cout F and cout, and we output the values. So what I'll do is run the program, and we'll check that the values of F and C are correct. So it'll take a moment to compile, and you'll see here, you can check it for yourself if you want, but we have C set to 33, and F, after the conversion, it's 91.4. So 33 degrees Celsius is 91.4 degrees Fahrenheit. And that concludes this exercise on recognizing parts of a C++ program and the use of the C++ preprocessor.